Hello everyone, today we're going to understand the working of a four-cylinder inline engine, the one you see on screen. This is the most common engine design in the world. You'll find it in most cars, motorcycles, and light commercial vehicles. The reason is simple, it offers the perfect balance of power, smooth operation, and fuel efficiency without being too complex or expensive. Let's start with the main parts. At the bottom, you see the crankshaft. This is the backbone of the engine. Its job is to convert the up and down motion of the pistons into rotational motion, which eventually turns the wheels. Connected to the crankshaft are the connecting rods, and on top of those sit the pistons. They move inside the cylinders. At the top of the engine, you'll notice the camshaft. This shaft has specially shaped lobes that press down on the valves. Each cylinder has two valves, an intake valve that lets in the air-fuel mixture, and an exhaust valve that pushes out the burned gases. The valves are held closed by valve springs, which snap them shut the moment the camshaft lobe moves away. Now, how does this engine actually run? It works on the four-stroke cycle, meaning each piston completes its work in four stages: intake, compression, power, and exhaust. Intake stroke, the piston moves down, the intake valve opens, and the air-fuel mixture is sucked into the cylinder. Compression stroke, the intake valve closes, the piston moves up, and compresses the mixture. This raises both pressure and temperature inside the cylinder. Power stroke, the spark plug fires, igniting the mixture. A small explosion pushes the piston down with great force. This is where the engine gets its power, which turns the crankshaft. Exhaust stroke, the piston moves up again, the exhaust valve opens, and the burned gases are pushed out. Here quotes the important part: all four pistons don't do the same stroke at the same time. They follow a specific firing order, usually 1 3 4 2. While piston 1 is on its power stroke, piston 2 might be on exhaust, piston 3 on intake, and piston 4 on compression. This way, the crankshaft gets a power push every 180 degrees of rotation, which makes the engine run smoothly without heavy vibrations. The timing between the camshaft and crankshaft is absolutely critical. They are connected by a timing belt or timing chain. The camshaft rotates at exactly half the speed of the crankshaft, so for every 2 rotations of the crankshaft, the camshaft completes 1. This ensures the valves open and close at precisely the right moment. The valve springs also play a key role. When the camshaft lobe presses the valve, the spring compresses. As soon as the lobe moves away, the spring snaps the valve shut instantly. If the timing is off by even a fraction, the piston can hit an open valve, causing serious engine damage. So why is the four-cylinder design so popular? Because it balances everything. With 4 cylinders, you get a power stroke every half turn of the crankshaft, which reduces vibration and gives a smooth driving experience. It's compact enough to fit in small cars, yet powerful enough for everyday driving. It's also cheaper to build and maintain compared to 6 or 8-cylinder engines, and it gives better fuel economy. Every part you see: pistons, connecting rods, crankshaft, camshaft, valves, and springs works like a synchronized team. The pistons provide the force, the crankshaft converts it into rotation, the camshaft controls breathing, and the valves manage what goes in and what comes out. All of this happens hundreds of times per second when you're driving at high speed. That's why, even after more than a century of automobile history, the four-cylinder engine is still the heart of most vehicles on the road today. It's reliable, efficient, and brilliantly engineered.